discussed. Anybody? Unmute and tell me what we discussed.
Lab activity.
Lab activity. Then after, we generalized one table, right? That which is given in the textbook in the page number 70. That help you to write the characteristics of the image formed by a concave mirror, right? By knowing the position of the object. Position of object, right? And the type of mirror is concave, right? So here, what are the noun places? 6 places are there. That we will see once again. So I will show you with the diagram. So here, what are the various positions possible, right? What are various possible positions to place the object on the principal axis of a concave mirror, right? So here, for that, just I am using the concave mirror here on the screen. Just look at here, how many places you know in front of the mirror? Anybody? Noun places in front of the mirror. Noun points are there, that are dots we used on the principal axis. Don't know. There are 2 points here. One is focus and the other is center of curvature, right? One is focus and the other is center of curvature, right? Here, simply I'll put the object at different places, right? First possible place is at very far from the center of curvature. That means from the mirror actually, outside of the center of curvature, very long distance, that we can call it as infinity distance, right? Very far from the, sorry, lens written here, it is mirror. Very far from the mirror. So it is infinity position. What it is? Infinity position. So for this position, we cannot show the object. Only we can use the parallel rays. We can use the parallel rays, not showing the object. Then what is the second position possible here? Outside the center of curvature. That we can call it as beyond C. Sir, what is the difference to the first position and second position? Both are beyond C only. But the first one is very far from the center of curvature, right? Second one is just a second. Any problem in joining in the meeting for you? Have you got any problem, difficulty? Surajita, Kaushik, anybody answer me? Abhinaya? Sir, Abhinay?
No, sir.
No, sir. So again, it is asking me same passcode 1 2 3 4 5 6. Okay. So here the difference is simply one is near to the center of curvature, one is very far from the center of curvature. So very far case we'll use infinity, right? Then for the second one, outside the center of curvature, we can call it as beyond C. The position of object is known as beyond C. So we will show the object beyond C here, as you see on the screen. Using upward arrow, always the object is placed above the principal axis, right? So in this case, just here we are showing the object on the principal axis outside the center of curvature. Then the next one is bringing the object towards the center of curvature. That position is called as at center of curvature or at C. So in this case, we'll show the object exactly on the center of curvature as you see here, right? Object placed exactly above the principal axis at center of curvature. Next position, just moving inside. So that we will call it as between focus and the center. So between F and C. That position we can write as between F and C. So object shown as upward arrow between F and C. Between F and C. Then simply you are showing the arrow between F and C. Next position. Next position.
At F.
Right, at F. So we will draw the arrow exactly at focus. Right, at F, we can say that position name is at F. Then next position is moving inside the focus, right, between P and F. So here simply to get the positions of all these, I am depending only on the 2 points here. This place is outside of the C. This is between F and C. This is, I am depending on the pole between P and F. So based on that, I classified this. Everyone is clear? Right, thank you. So we'll go for the next one. That is the topic is simply, I forgot here. For any position of the object, commonly I am using one rule, which is related to the concave mirror. What is that? Simply rule 1. See here, the ray which is joining all the top points of objects. Is it clear? What is commonly I am using in all the ray diagrams? Parallel light ray, that which started from the top of the object. R1 I am using commonly for any position. I shown 5 positions by keeping the object above the principal axis. For all these, I will use a ray commonly. That is R1. Right? That is R1. Just a second. Sricharan is able to join. I'll share the link to him. So once look at the rules, concave mirror. Look at the rules for the concave mirror. Right. Have you observed that rules? Anybody? Tell me the rules, what the rules are. What the rules are. Anybody? What the rules are? What the rules are? Don't know? That rules are simple. Generalized rays. Generalized rays. One is parallel to the principal axis. Second, passing through the focus of the mirror, and the other is along the normal. These are the generalized rules. R1, R2, R3, right? So by using them, we are trying to draw the ray diagrams. So we will go for the topic is drawing the ray diagrams for concave mirror here. So for these, we have various positions. Very first position is from very long distance. We can call it as object placed at infinity. I am showing the object in this case. Will you show the object in this case? Anybody? Can we show the object in this case, infinity? No, we are not showing the object in this case. Just we will use parallel beam of light rays. So for that, just I am following the steps, drawing the principal axis, right? Identifying the center. I see. Then for cutting the arc, I will open the compass radii as 12 centimeters, right? Then cut the arc using 12 centimeters radii for your compass. Then shade it to make it concave mirror. Then identify its pole and center of curvature at focal point or focus at 6 centimeters distance from the pole, right? Then what to do? Instant the parallel beam of light ray. Instant the parallel beam of light ray. Then what happens? Then what happens? So here, what the ray or rule I am following here? How it is? Suppose this is a ray I am using. How it is to the principal axis? It is looking like R1 or R2 or R3. What is the range?
R1.
R1. Why R1? Here it is parallel to the principal axis. So all are parallel to the principal axis. So we generalized already. What happens if a ray incident parallel to the principal axis on a concave mirror? After reflection, that light ray? Anyone?
Passes through focus.
Very good. Passes through the focus. Only one ray or anything? Any ray. So where first ray I shown along the principal axis. Why? First ray, that is here, this one. Along the principal axis, one ray is there. That after reflection also I shown along the principal axis. What the reason is?
Because angle I is equals to angle R.
What is the angle I?
Angle I is 0 and angle R also 0.
So what we can call that? Instant normally, right? In this case, we can call it as instant normally. So that's why I shown the ray after reflection along the principal axis. Then what about the remaining rays above and below? They can reflect back as per the rule 1. After reflection, they can pass through the focus, right? This is the ray diagram. Then can you help me to write the characteristics of the image? Characteristics of the image. Where is the image actually? Do we get converging point or diverging point after reflection? What do you find?
Converging point.
So converging point will give you real image or virtual image?
Real image.
Real image. So one is, you said, real image. Okay. What about the other characteristics we need? Position. Where is position? Where is position? At the converging point. At the converging point. Where is converging point?
At F.
At F. Then can you say about the size of the image?
Point size.
Very good. It is point size, right? Then is it real? Sorry, is it inverted or erect image? We cannot decide because it is a point image. Is it above or below? We cannot say, right? It is a point. So what the characteristics we can write for this here? It is real image, and we cannot say it's a type, either inverted or erect. We cannot decide. Then it is a point size image. Finally, it is formed at focus. So these are the characteristics of the image formed by a concave mirror when the object is placed at infinity. Is it clear, everyone? Use your quick reaction. How to draw the ray diagram. So you can follow the mathematical process. Definitely you will get the characteristics of the image as I shown you, right? So we'll go for the next case. Can anybody help me? What is the next position? I am coming from very far distance. What is the next position? Second position. Very far from the mirror. I am moving towards the mirror. So what point?
Beyond C.
Very good. Beyond C. The second position is beyond the center of curvature. So for that, I will follow the same process. Here, look at, I am showing you clearly. First of all, use your paper horizontally, then put the scale. Better to use long scale, right? Better to use long scale, then cut horizontal line here. Draw a horizontal line on the paper as you see here. Then what to do? Identify a point at a 12 centimeter distance from left end, right? From the left end, right? I am drawing the concave mirror, left side. Always I will draw the concave mirror, left side of the horizontal paper, as you see on the screen. Then what to do? Identify the noun points, pole, focus, and center of curvature. So here I am showing you 5, 5. Based on the page size, you can follow 6, 6 centimeters or 7, 7 centimeters also, but equal distances, right? So here 5 centimeters, 5 centimeters. That means at 5 centimeters, 1 point, and 10 centimeters, 1 point identified by me. So one is focus and the other is center of curvature. Then as object, I am using here one upward arrow. That upward arrow height also I'll follow logically. That is exactly width of the scale. So position is beyond the center of curvature. So I placed the scale as you see on the screen. Then I'm drawing a vertical line upward to the principal axis. As you see here, exactly width of the scale. Why I use it like this? To draw the parallel light ray to the principal axis logically. So here it is easy for me to select a point top of the object and drawing the ray 1 from the top of the object as you see here, right? Then what to do? What to do? Then remove your scale. Next, second ray I required. So here second ray is possible or to passing through the focus. Yes, possible. So I will connect the top of the object and focus with the scale, right? Then I will draw the R2 instant on the concave mirror, which is passing through the focus. Then remove the scale. So I got 2 rays from the same point, that is top of the object. Then what to do? Draw the reflected rays as you generalized. So R1 is parallel to the principal axis. After reflection, it passes through the focus, right? So here, place the scale as you see here by joining the point of instance given by the R1 and focus. Then cut the ray, reflected ray, which is passing through the focus. So first one is completed. Then second one, passing through the focus, passing through the focus, that will reflect the back, right? Okay. Then after reflection, it becomes parallel to the principal axis. Draw a line, that means a ray, which is parallel to the principal axis from the point of incidence here. This is the point of incidence. So from there, you can draw a ray that which becomes parallel to the principal axis. So here the topic is clear. If it is clear, then we will go for the characteristics of the image, right? Characteristics of the image. Any issue? How to draw the ray diagram? Any issue? If anything is doubt, just raise your hand. Otherwise, I will go for the next concept. That means next diagram by writing that. Then here, do you get converging point or diverging point after reflection? What you see here, converging or diverging point? This one,
Converging point.
converging point. So what type of image you are expecting here?
Real image.
Real image. So here, to show that image from this point, you have to draw a perpendicular onto the principal axis, as you see here. Look at why I shown the direction downward for the image, because that converging point by the reflected light rays given below the principal axis, right? Then where do you get the bottom of the object? So if you select this, the ray which passes through the principal axis or center of curvature will be reflected back in the same direction. So the image of the bottom of the object will be obtained here. So that's why we are using the direction in reverse order. Is it clear, everyone? Is it clear? Yes. Right. Next, characteristics of the image we have to write. What you can write, the characteristics of the image formed by the concave mirror when the object is placed beyond the center of curvature. So look at the first one I am writing. Is it real or virtual? Is it real or virtual?
Real image.
Real image, because it is in front of the mirror. So the image type is real. Then second one I required, is it a inverted image or erect image?
Inverted.
Inverted image. The third one I required, it's a size smaller or more than the object, greater. If it is smaller, we can use one term particularly. If it is greater, we can use another term. What is?
Diminished.
Very good. It is diminished. Then position of the image. Position of the image.
Between
Between
focus and
F and C.
Very good. Between F and C. So these are the characteristics of the image. Is it clear, everyone? How to draw the ray diagram easily? So follow the same logics when you draw the ray diagrams for any position of concave mirror, right? Then we'll go for the next position. What is next position here? What is next position? Anyone?
Let's see.
Very good. So beyond to center of curvature now. So object is placed exactly at center of curvature. So I am following the same logic. First, I am drawing the principal axis, then cutting the arc using the same distances as you learned in the previous diagram. So make it concave mirror, then identify its pole, focus, right? And the center of curvature following the same distances here. Then put the object exactly at center of curvature, that height of the object exactly equal to the width of the scale at center of curvature. Then object drawn. Then complete the ray one before removing your scale, right? So it is parallel to the principal axis, which is started from the top of the object. Then remove the scale. Second ray is possible. What is second ray? Passing through the focus. Is it possible? Yes or no? Look at here. Yes, possible. From the top of the object and connecting the focus. So if I draw a ray, it meets the mirror. So second ray also possible. So R1 possible, R2 possible. No need to go for the third one. Right? So I got incident light rays, at least two from the same point of the object. Okay, that step completed. Then what to do? Construct the reflected light rays of these. First one, R1. So after reflection from that mirror, it passes through the focus. So what to do? we have to connect the point of incidence and focus with the scale, then draw the ray, which is reflected from the same point. Then a ray which is passing through the focus after reflection, it becomes parallel to the principal axis, parallel to the principal axis. Then remove your scale from the point of coincides, that reflected rays where they are going to meet each other, that point we can call it as converging point of reflected light rays. So from this point, what to do? We have to draw a perpendicular onto the principal axis, right? Where I got the image? Anyone? Where I got the image?
Let's see.
At C, right? Then I will write the characteristics of the image formed by the concave mirror when the object is placed at center of curvature, right? So object placed at center of curvature completed that construction of reflected light rays using the R1 and R2. So I got the image at C exactly. So now the characteristics, first one is it real or virtual? It is real because I got the image by the actual converging of reflected light rays. Then I'll go for, is it inverted or erect? So it is oppositely faced to the object. Then it is called as inverted image. Then the third one is size, same size. Then position is exactly at same point, C. So these are the characteristics of the image. Is it clear, everyone? Go for quick reaction. Only 2 are given. Okay, 3, 7. Right, thank you. Then what is next position here? At center of curvature is completed. Next position is moving inside the center of curvature. That position we can call it as between F and C. So same process we are following, constructing that concave mirror using the same logics, identifying the pole, focus, and center of curvature, and showing the object between F and C, that exactly width of the scale, right? Draw the parallel light ray to meet the principal axis from the top of the object. This is R1. After reflection, it goes through the focus. Then remove. Then secondary also possible, that which is passing through the focus, right? Which is passing through the focus. Then construct its reflected rays. So parallel ray passes through the focus after reflection. So construct that reflected ray for R1. Then second ray that passing through the focus after reflection, it becomes parallel to the principal axis. So I got converging point of reflected light rays. So from that point, I can draw a perpendicular onto the principal axis. This is as image for me. This is image. Then I want to write the characteristics. Can anybody answer me? What are the characteristics? 4 places, 4 characteristics. First one is type, real or virtual. First one is real or virtual. Anyone?
Real image.
It is real image. Second one, it is about inverted or erect image.
Inverted.
Inverted. Third one, I am asking you about size of the image. Compare the sizes.
Magnified.
Magnified or enlarged, both we can write, anything. Both are accepted. Then position finally.
Beyond C.
Beyond the center of curvature. So these are the characteristics. Clear, everyone? Go for quick reaction. Right. So now we'll go for another position of the object, that is 5th position between completed. So now we are moving towards what? Focus. So exactly I'll stop at focus. So that position of the object we are showing with the same logics what we learned. identifying the pole, focus, center of curvature, maintaining the gaps between P and F and F and C, same. Then construct the object using the height, width of the scale, then identify it as object, then draw the parallel light ray R1 to meet the concave surface from the top of the object. After that, second ray is possible, auto here, anyone? Auto is possible, passing through the focus.
No, sir.
If you draw, what happens? Suppose, if you draw, what happens? A ray which is started from the top of the object, right? A ray which is started from the top of the object and it is passing through the focus. Will it meet the mirror surface? If I go for R2, will it meet the mirror surface for any extension?
No, sir.
No. So that's why we are not going for the R2 here. Clear? Right. Now, what is another ray possible here? R3 or R4. So R3 possible or not, we can check. So here, how to check? Just use your scale to connect the top of the object and the center of curvature. Is it going to meet the mirror surface or not? That you have to check. If not meet, just you have to increase the curvature size, concave mirror, extend it. Okay, so R3 is possible. So what I am doing here, constructing the ray. Now I have two types of rays that which are we learned as R1 and R3 rays. So what is the behavior of R1 here after reflection? It passes through the focus. So we can join point of incidence and focus, then drawing the reflected light ray. Then what to do? R3 we have to get. So R3 behavior is what? Anyone? What is R3 behavior? R3 behavior.
When a light ray passes through center of curvature, it reflects in the same path.
Very good. So it is looking like coming from the focus, right? But we did not start that like that because we need only from the top of the object. That's why I used it here to connect a center of curvature and top of the object logically with the scale I shown. So it is looking like passing through the focus onto the mirror, right? So that logic we are following here. Okay, then after reflection, it goes or passes through the center of curvature, right? Then tell me how they are. Reflected light rays.
Parallel.
They are parallel to each other. If I extend that light rays in front of the mirror or behind the mirror, do they meet? Will they meet? They never meet in front of the mirror or behind the mirror. Anywhere they cannot meet. So in this case, where we can get the image, you cannot find. So where we can say, I am unable to find by moving any distance in front of the mirror or behind the mirror. So behind the mirror, it is impossible to move infinity distance. Only it is possible in front of the mirror. And one more point, I am unable to see image on the mirror surface, right? So is it virtual image? So because of this, it is not a virtual image. I can conclude that. So it is not virtual. What the maybe image is real image, right? So that image characteristics, we can write it as it is real image. And the type of image is inverted image only, real image always inverted image. And the size of image is highly enlarged. Then the position of image is infinity. Nobody can see that. So these are the characteristics of the image. Any confusion? Any confusion? Go for quick reaction. Yes or no? So no confusion. So we will end this session now. Then rejoin using the same method you followed to join the class. Thank you.